All right, so we have a dietitian in a hospital is to arrange a special diet using two foods. Each ounce of food M contains 30 units of calcium, 10 units of iron, and 10 units of vitamin A. Each ounce of food N contains 10 calcium, 10 iron, and 30 A. Now, the minimum requirements of the diet are 360 rather, of calcium, 160 of iron, and 240 of vitamin A. Now, if X is the number of ounces of food of M, and that's used, Y is N. What we want to do is find, again, a system of linear inequalities that reflects the conditions indicated, and then we need to find a set of feasible solutions graphically for the amount of food that can be used. All right, so for uh, for M, here we go. What we have 30 calcium, we have 10 iron, and we have uh oops, I guess we have 10 of A. We'll just write it like that. And for N, we have what? We had 10 calcium, we had 10 iron, and we had 30 of A. Okay. And we have some numbers we have to be. The calcium minimum requirement, so it has to be greater than or equal to what? 360. The iron has to be greater than or equal to 160. And the A has to be greater than or equal to what? 240. And we're saying that X is M, Y is N. And again, you could use M and N, but we're going to use X and Y. And so what we're going to do is we're going to take each of these things and put them into things. So now we're going to take that 30 times X plus 10 times Y has to be greater than or equal to, and that's the 360 for the total calcium. Then we're going to go across here, 10 and 10, and it has to be greater than 160. So 10x plus 10y greater than or equal to 160. And now we go across 10, 30, and greater than 240. 10x plus 30y greater than or equal to 240. And what are our normal constraints? Well, x has to be greater than or equal to 0, and y has to be greater than or equal to 0. So those are our original constraints here. Now, solving each of these for y. So y in this case is going to be what? Greater than or equal to a minus 3x plus, and that's going to be a 36. Doesn't look good there, but oh well. And this one's going to be y is going to be greater than or equal to what? Well, it's going to be a minus, and that's going to be divided by, so that's just going to be an x, and that's going to be plus 16. And here we divide, so y has to be greater than or equal to what? Well, that's going to be a minus 1/3 x, and then that's going to be plus, and then that's 3 goes in our 8, so 8. Okay, so those are our three inequalities. And again, we're going to be just in that upper quadrant, so it's going to look something like this. And so at 36, we're going to have one of them up here. One's going to be 16, so it's going to be, I don't know, somewhere here, and then 8. Okay. Now, the 8 one is going to be more shallow, so it's going to be kind of coming down, something like that. The one at 16, it's a little steeper, so it's going to come down, and it's going to be something like that. And the one at 36 is pretty steep, and so it's going to come down, and my lovely straight lines here, something like that. Okay. And they're going to be greater than all of those. So that means if they're greater than all of those, it's going to have to be this region up here to be greater than all of those. And again, so we go up like that. And if we take this one, it's going to be over like that. So everything up in that region is going to be there. So it's going to be unbounded. And so that means we have to find this point. Well, guess what? We found that one already, 0, 36. We have to find this point. We have to find this point, and we have to find this point. Well, that point is going to be if we plug in 0 for y, take that over, multiply by 3, you get 24. So that's going to be a 24, 0. So we've got those two. So now we just have to find those 2 points, and we're going to do that with the calculator. We could do it by longhand if we wanted to, but we're just going to get used to using our calculator to do some of this stuff. All right, so again, we're going to have to plot all those again. So that's a minus 3x and then plus 36. And then we have a minus x and then plus 16. And we had a minus 1/3 x and then plus 8. Okay. Now, graphing that, we probably don't need as big a window. If I remember, those windows were pretty big. So maybe let's just go to 30. We can go back to maybe by 5. This one, we only have to go maybe at 40. And again, let's do that by 5. I think that should get us in the region. There we go. Now, not really a nice region here, so maybe we should really go from 0 and 0, and then we're only looking at the region that we have. And so then we're looking for that point and we're looking for that point. So second trace, we want an intersection and we want the blue and the red. That's fine. So that gives us 10, 6. And so that's going to be our top point. Then do another trace for intersect. And now let's do red and black. And that's going to be 12, 4. So that gives us our last 2 points. And that last one was 12, 4. And the other one was 10, 6. So now we know all the different points here that are the corner points for the feasible solution. And we know it's, unbounded, it's going up like that. And so that's going to be our solution to this set. All right, so that's all I have for this section. So hopefully that helps.